All right, picture this. You're sitting right there in the exam hall. The clock is ticking down, the silence in the room is deafening, and you flip the page of your Cambridge Mathematics 9709 past paper. Bam! You are staring down a multi-part, incredibly complex calculus question. You can practically feel the deadline pressure mounting in your chest, right? Specifically, it's a 3.4 differentiation question. Now, this is the kind that tests absolutely everything you know from section 2.4, but now they've thrown in the derivative of inverse tan, or arctan, just to really test your mettle. Well, if you've ever felt that familiar wave of panic wash over you, you are in exactly the right place. Welcome to this explainer. Today, we're taking that panic and turning it into pure, calculated strategy. We're going to break down the story of the question, and I'm going to show you exactly how to deliver the headline, which is your perfect high-scoring answer. Think of this as your ultimate examiner playbook.
15%. I just want you to let that sink in for a second. This specific topic, 3.4 differentiation, including the derivative of inverse tan, accounts for approximately 15% of the total marks in the Mathematics 9709 exam. That is a massive chunk of your final grade wrapped up in just one conceptual area. If you can master this, you're effectively building an absolute fortress around a fifth of your entire paper. But on the flip side, if you ignore the examiner's specific requirements, you're leaving an enormous amount of marks just sitting on the table. We aren't just learning math today, we're learning exactly how the Cambridge examiners think and how you can use that psychology to your absolute advantage.
So here is our roadmap for today's explainer. First, we'll look at the challenge of deadline pressure. Then, the core principles of differentiation. Third, we'll dive into the vital method mark strategy. Fourth, we'll cover some serious examiner warnings. Fifth, we'll elevate to critical analysis. And finally, we'll tie it all together into the final system. Let's get straight to it. Okay, kicking things off with part 1, the very real challenge of deadline pressure. I want you to imagine a dynamic split screen in your head right now. On the left side, we have a typical student, let's call him Alex. On the right side, we have another typical student, Sam. Now, both of these guys are highly capable, both have studied the syllabus codes, and both are staring at a complex differentiation problem involving the chain rule and the derivative of inverse tan. The timer's ticking down, 60 seconds, 30 seconds. The pressure is intense, and under this kind of deadline pressure, their true exam habits are revealed. Unfortunately, both are making critical grade-costing errors. Alex's approach on the left is a classic case of information dumping. Alex sees the inverse tan function and immediately overloads the page with raw mathematical facts. He writes down the formula. The derivative of inverse tan x is 1 over 1 plus x squared. Great, but he provides zero analysis. He doesn't actually apply the chain rule to the specific function inside the bracket. Now look at Sam's approach over on the right. Sam completely rushes the process. Sam actually knows how to do the math, but entirely misses the command word requirements in the question, like hence, show that, or evaluate. Sam skips critical steps of the working out just to race to the final answer. So what happens? The examiner's red pen strikes both of them. Neither gets full marks. Alex lacks application and Sam lacks procedural evidence.
Which brings us to part 2, the core principles of differentiation.
To shift away from these chaotic, pressure-induced mistakes and build a really solid theoretical foundation, we have to look at what the examiners are actually measuring. The conceptual framework for 3.4 differentiation doesn't just rely on memorizing formulas. Cambridge assessment objectives for this topic actually target 3 distinct cognitive domains. Imagine a pie chart. The first slice of the pie is knowledge and understanding. Basically, do you know the standard derivatives? The second slice is application. Can you apply the product, quotient, or chain rule to a completely novel function? But the third slice, analysis, is where the top students really separate themselves from the pack. Can you take a complex derivative, set it to 0, analyze the stationary points, and justify whether it's a maximum or minimum using this second derivative? If you only have knowledge, you only get a fraction of the pie. You need all 3 to secure those top marks. It's all about providing a logical trail of breadcrumbs for the examiner to follow. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at part 3, the incredibly important method mark strategy.
Cambridge mathematics exams use a really specific marking scheme where marks are awarded for the process itself, not just the final correct answer. These are your M marks, meaning if you make a tiny arithmetic error in line 2, but your differentiation technique is completely sound, you can still secure the vast majority of the marks for that question. But here's the catch. You have to prove your method. Top students internalize a precise 4-step procedural framework to guarantee these marks even when they're panicking. Step 1. Deconstruct the question. Highlight those command words. Are they asking you to differentiate, find the exact value, or show that? Step 2. Extract relevant data. Write down your U and V clearly if you're using the quotient rule. Step 3. Select your analytical framework. Are you using the chain rule? Actually write it out. Step 4. Execute with clear notation. Please, don't jump from y straight to the answer. Show dy dx. Show your substitutions. By following these exact steps, you are essentially building yourself a safety net. Even if your final calculation is slightly off, the examiner sees your robust framework and hands over those method marks.
And look, strict conventions really matter here. Practical application of mathematics develops professional skills, and that means your format and terminology are heavily scrutinized by Cambridge examiners. You need appropriate formats and crystal clear annotation. If you're finding the second derivative, clearly annotate it as d squared y over dx squared, or f double prime of x. Whatever you do, don't let your working bleed into one giant illegible paragraph of numbers. Structure it. When examiners see a well-organized, logically formatted answer, it instantly communicates competence. It tells them that you are in control of the math, not the other way around.
I want to highlight a massive examiner alert pulled directly from the principal examiner reports. It says, candidates consistently confuse key terminology. Always define terms before using them in extended responses. In the context of differentiation, this means clearly stating what you're actually finding. If the question asks for the gradient of the normal, don't just calculate the derivative and stop there. The derivative gives you the gradient of the tangent. You need to explicitly show the step where you take the negative reciprocal to find the normal. Terminology confusion is exactly what turns green check marks into red pen marks. Be explicit.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, moving right along to Part 4, the top 3 examiner warnings. So, we've looked at what you should do, but let's rapid-fire the 3 major pitfalls that trap thousands of students every single year. You can use this as a quick mental diagnostic tool for yourself. Warning number 1, answers are too vague. When asked to interpret a derivative in a real-world context, say a rate of change question, students often just say, it's increasing. Nope, the examiner wants specific details. You should say, the volume is increasing at a rate of 5 cubic centimeters per second. Warning number 2, format and presentation are totally forgotten under time pressure. The math just degrades into a chaotic scribble. Don't let that happen. And warning number 3, answers are not specific to the given context. If a question limits the domain of x from 0 to pi, and you provide an answer outside that domain just because you blindly solved the equation, you are going to lose marks. Always check the context.
Okay, let's put this into practice with a quick interactive workshop. Take a moment to read this rushed mathematical response regarding a differentiation problem. We're going to evaluate it using the Peel framework. That's point, evidence, explanation, link. A student wrote, the derivative is 2x, so the function goes up. This means the gradient is positive. Can you extract the core trend and spot the flaw here? I'll give you a second. Got it? The flaw is that it completely lacks specific evidence and explanation. Saying the function goes up is way too vague. A top-tier Peel response would sound like this. Point. The gradient of the curve is positive for x greater than 0. Evidence, because dy over dx equals 2x, which is greater than 0 when x is greater than 0. Explanation. Therefore, the function is strictly increasing in this domain. Link. This confirms the nature of the curve shown in the given context. Do you see the difference there? It is all about precision.
That naturally leads us right into Part 5, mastering evaluative thinking.
To achieve those highest-order assessment objectives in 9-709 mathematics, you can't just be a human calculator. You really have to be a mathematical thinker. Notice the 3 levels of the critical analysis framework we've got here. The descriptive level is just the baseline. You state the derivative of inverse tan. The analytical level is the middle tier. You apply that derivative using the chain rule to a complex equation, and you find the turning points. But the evaluative level, this is where the top-tier grades live. This is where you compare different mathematical approaches, evaluate the validity of a mathematical model based on your derived results, and provide completely justified recommendations. You aren't just solving, you are proving exactly why your solution is the most appropriate one based on rock-solid mathematical evidence.
And when you're asked to compare mathematical models or functions, understanding the duality of similarities versus differences is absolutely key. If a question asks you to compare the gradient of two different curves, you must use comparative connectives. Don't just list the properties of curve A and then separately list the properties of curve B. You need to say things like, whereas curve A has a constant positive gradient, curve B's gradient is exponentially increasing. You must support each and every comparison with numerical evidence derived from your differentiation. Use words like however, conversely, or in contrast. This is the exact language that signals true evaluative thinking to the examiner.
Okay, we are in the home stretch. Part 6, the final system. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Let's condense everything we've talked about, the common mistakes, the method mark strategy, the examiner warnings, the evaluative framework, into the ultimate mathematics success blueprint. Here are the final 3 rules that, when combined with the method mark strategy, will completely transform your test-taking ability. Rule 1. Command word decoding. The literal second you read the question, circle the command word. If it says show that, it means the answer is already given, and the marks are entirely for the intermediate steps. Rule 2. Procedural framework application. Use that Peel method for any written explanations, and always lay out your algebraic steps clearly. Extract the data, select the rule, execute with proper notation. Rule 3. The time management matrix. 15% of the exam marks means you should spend roughly 15% of your exam time on this topic. Please don't get bogged down on a tiny 2-mark question for 10 minutes. Move strategically.
I want to share this really powerful direct quote from the Principal Examiner reports because it ties everything together beautifully. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying decisions with evidence. This is the ultimate standard you should be striving for. The examiner isn't your enemy. They are actively looking for reasons to give you marks. Your job is just to make it incredibly easy for them to do so by presenting a clear, justified, and structurally sound mathematical argument. You are basically a detective presenting an airtight case. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCE and click that bell. Don't let another exam pass you by. Because here's the truth. Knowledge without execution is entirely useless under deadline pressure. Knowing what the examiners want is only half the battle. The real test is applying these frameworks when the clock is actively ticking and the exam hall is dead silent. So how will you implement the method mark strategy in your next 9709 past paper practice? Will you let the timer dictate your grade, or will you use this blueprint to dictate the timer? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Thanks for joining this explainer, and we'll see you next time.